Hello. Today we're going to deal with a fun topic. What is time? And rest assured, I hope you'll agree when we finish this that time isn't what you think it is. So let's jump into it. Here we go. Here we got this. Okay. So what we have here is a picture of a clock, and we'll get to that. We have up here the graphic showing the curvature of space-time, which is going to be part of this. And over here, we have a picture of a destroyer escort that's going to be involved in time travel, which is bizarre, but as we'll see, there's nothing about time that's really obvious. Time is very different. So here's our outline. I'm going to start with trying to talk about what time is. We'll go into special relativity, where the faster you go, the slower time gets. We'll go into general relativity, where the greater the gravity is, the slower time gets. And then we'll look at the difference between the macrocosm and the microcosm. In the macrocosm, things take on a continuum of values. In the microcosm, there's only discrete or so-called quantum values that are allowed, not any old value. And then we'll look at an interpretation of timelines, which comes out of quantum mechanics. And related to that, there's the Akashic thread from the Vedic manuscripts, the Akashic thread of the immortal soul that we'll touch on. And then we'll spend some time on a time travel experiment that took place in August of 1943 in Philadelphia. So what is time? Well, most people look at a clock or a watch and they say, oh, this is what time it is. But actually, that isn't anything. That just says what the clock measures. So what is time is the real question here. So if we go back to Newton, for example, in 1687, he wrote a monumental work called Principia, and he talked about the three dimensions of space. Each dimension of space can be measured in part. You can go forward and backward in each spatial dimension. So the three spatial dimensions have those attributes, but time is different. Time is different than space. There's a past, which is always receding from us. There's the instant of the present that we live in, we think we live in, and then there's the future that's ahead of us. So time goes in one direction, apparently, from the past to the present to the future. We can't go forward and backward in time like we can in space. And this is just the start of it, as we'll see. When we get into special relativity, it turns out that this was implicit in, it was presented in 1905 by Einstein, but in fact, it was implicit in the early 1860s when Maxwell developed his equations of electromagnetism. And he noted that there was a special speed, the speed of light, that determined how fast electromagnetic energy could propagate through space. And it was, we've measured it, and I'm just saying it's roughly 3 × 10⁸ meters per second. But that's all well and true. What Maxwell missed was that in 1847, the German Grassmann had developed something called exterior calculus, which most physicists just simply couldn't understand. But he actually developed Maxwell's equations in 1847, and I went ahead and clarified this to point out that there's what is called a gauge function. When we take its exterior derivative, or its gradient, we get a potential function. When we take the gradient of that, we get a field. When we take the gradient of that, we get a current density. When we take the gradient of that, we get what are called sources. These are the sources for electricity and for magnetism. So this all leads to the notion of special relativity, that as you increase your velocity, time slows down for that observer relative to the time of a stationary observer. So in other words, your clock, if you had one with you, would slow down if you could compare your clock to that of a stationary observer. So already things are getting strange. Einstein generalized this to general relativity in 1915. And in this theory, he argued that gravity is created by the curvature of space-time itself. So here we have a massive entity, the Earth, and this satellite that's here in orbit around the Earth keeps falling toward the Earth, but the falling is created by the curvature of space-time that the satellite is in. So it goes in an orbit, constantly falling toward the Earth, but never quite making it because it's going fast enough to stay in orbit. So what happens out of this is that as gravity increases, time itself slows down. So this is strange. Let's take an example. Suppose you had a watch tied to your shoelaces and you had a ball cap on with a watch tied to that. Well, the shoelace watch is closer to the center of Earth, and therefore the gravity is slightly stronger than the gravity for the watch tied to your cap. So the watch on your shoelaces runs slightly slower than the watch on your head. Now, how much is this? Well, let's just try and quantify it just so you'll see what's going on. Suppose you're 6 feet tall, which is about 180 centimeters. The radius of the Earth is 3,900 miles, which is 630 million centimeters. So if we take the ratio of 180 centimeters to 630 million centimeters, we come up with something that's on the order of 10 to the minus 14th. So the clock is slowing down by less than a millionth of a percent. But it is running slower. It's just very hard to go measure something like this. So there we have the coupling of gravity and time. Now let's turn to the macrocosm. And in this world, there's mechanics, and they involve forces and energies, and they can take on a continuum of values. Anything will do to 6, 10, 12 decimal places. But when we go down to the microcosm, the world of the atom, we find that their energies can only take on discrete values. And so if a particle moves from one energy level to another, only a discrete set of values are permitted for this transition to take place. And the time it takes to go from one energy level to another is going to implicitly define the shortest amount of time in the world of the microcosm. In the world of the macrocosm, time is continuous. In the world of the microcosm, time is discrete. The discreteness is set by the time it takes to move from one energy level to another. So I've got an example here showing different things related to hydrogen. Let's look at hydrogen in some more detail. So the hydrogen atom is the most common atom we find in our universe, and it consists of a single positively charged proton in its nucleus, and then a single negatively charged electron that runs around it. So there's two possible states. There's other states here, but these are the two most likely states. One state is where the proton and the electron each have a spin that aligns with one another. So here they're both going up, as you see. And then here we have where the proton and the electron spins are opposite to one another. So here they're going down. One's going down and one's going up. And those are the two possible states that we come up with. And you can flip. In fact, these flips do occur from this state to that state and back again. But those flippings occur roughly on the order of 10, 11 million years. So it's infrequent that it happens, but it does happen, and that's enough to create a discrete energy here. So the energy that we come up with here, the difference in energy of these two states is proportional to a frequency of light, and light being energy is the frequency of it is inversely proportional to the wavelength. And so this turns out to be 21 centimeters roughly, or about 8.3 inches. So this was actually measured in the 1950s, and this was the first time it was possible to determine that the Milky Way was in fact a spiral galaxy. We had telescopes at the time that could see that other galaxies were out there and they were spirals. We suspected the Milky Way was a spiral, but it took this particular measurement here to determine that the Milky Way was indeed a spiral galaxy. So it's a very useful thing to have in your bag of tricks if you're an astronomer. What's somewhat bizarre here, if you go to the Temple of Saqqara in Egypt, there's numerous references to the 21 centimeter length. So what in the world did the Egyptians know about the hydrogen atom and this spin flip resonance here with a 21 centimeter wavelength? Who knows? But there's undoubtedly a story there. Now, a different thing that happens in quantum mechanics is that we have to solve a particular equation, the fundamental equation of quantum mechanics. And in solving this, it turns out that in the 1950s, it was discovered there was one solution to this that involved a so-called many worlds or many timelines, okay? So the solution is the following. Every time there's a transition from one energy level to another energy level, we have a new timeline or world. So if there is no transition, that's one timeline. If there is a transition, we get a new timeline. So here we have a picture of a movie, and the movie is splitting into two segments, two timelines here, one going this way and one going that way. This one has a cat in it that gets nailed by some poison, apparently, or some sort of radioactivity. That's the end of this cat. But in this other timeline, that doesn't happen. The radioactivity stays there. And so you can see that the cat is perfectly okay. So the cat is in two different states, dead and alive, two different timelines that come out of this. Now, these transitions that we're talking about occur upon billions and billions of times per second for every individual human being. There's 8 billion human beings roughly on Earth. So this is billions upon billions of billions just for the people on Earth, let alone the plants, the other animals, all the other things we see around us, and all the other planets and stars. So there's an incredible number of these so-called timelines or many worlds that are occurring. So, yes. What? Just doing a recording of a potential talk. I'm going to see how it goes. Okay. Yes, I will. Let me just finish. I won't be long. Okay. So it's interesting to note that in the 1500s, there was an individual, Michel Nostradamus, and he had this notion of timelines, and he wrote a series of quatrains that he described one possible major timeline for our history going forward in time. But he argued very strongly that this could be changed if people worked to change it. And his particular timeline described the advent of Napoleon, and then Hitler, and then an Antichrist out of the Middle East. Well, we've had Napoleon and then Hitler, but we have yet to see this Antichrist. And so apparently people read what Nostradamus had to say and they worked to change it. So the future can be changed, apparently. And what Nostradamus saw in terms of these timelines going forward has in fact been changed. So let's keep that in mind. Then we go to the world of India and the Vedic scriptures and the so-called Akashic records. Now, Akasha is the Sanskrit word for ether or sky or atmosphere. And in the scriptures, each of us has an immortal soul. The soul incarnates at birth with each human being and leaves upon death. The soul apparently resides linked through the different 7 major chakras that we have, from the top of our head down to our tailbone. And each of these 7 chakras apparently is made up of a small amount of what's called dark matter. Dark matter are subatomic materials. They're subquarks, analogous to the subquarks of matter. The difference is the subquarks of dark matter have no charge. So they only are bound by gravity, and by thermal effects, they can vibrate more or less depending upon how warm things are. And our soul is somehow linked to these chakras. So this immortal soul that's there, though, exists from lifetime to lifetime, and it contains a record of all the events in each timeline of the life of that human being. Upon death, the soul enters into a realm where this record is reviewed. Every single nanosecond of this record, the good, the bad, the ugly, everything that's there. And the intent is to see if the soul made any progress in goals that were set when it first incarnated. One of the problems with this incarnation process is you select a set of goals you're going to work on in this lifetime, but then when you incarnate, a so-called veil of darkness descends, and you can't see what those goals are. You don't know why you've incarnated in this lifetime. So this is the test here, is to see, did you in fact make any progress toward these goals? And so the history of humanity is really a tapestry. Each of these threads or Akashic records of each immortal soul goes into a tapestry that encompasses all of humanity, all the lives, all the lifetimes of the eternal immortal souls. So this takes us off to the geometry of our universe, and we're going to start to see where time really shows up here. Our universe consists of 26 real dimensions. 24 of them are spatial, and 2 are temporal. 2, not 1, but 2, as you'll see. So this 26 real dimensional space has 3 subspaces associated with it. It has 1 subspace with 9 spatial dimensions for matter, and 1 many worlds timeline dimension. So we have splitting upon splitting upon splitting of timelines. That is the time associated with this world of matter. And of the 9 spatial dimensions here, 6 are compactified dimensions. They're rolled up very tiny around the 3 large ones that we see around us. There's also 3 holes there in these compactified dimensions, which we'll come back to. In the dark matter subspace that's orthogonal to the matter subspace, we have, again, 9 spatial dimensions. And we have, for time, 1 Akashic thread dimension that goes on through all of time, all of the universe. We have 6 compactified spatial dimensions with 4 holes. And then above it all, we have a 6-dimensional compactified subspace with 8 holes. So if we look at this 8 holes here, we see that we have 3 holes connecting to the 8 holes from matter, 4 holes from the dark matter connecting to the 8 holes, And finally, the final hole connects to the two of the six dimensional compactified subspaces. So we end up with 8 holes interconnecting 18 compactified dimensions. So there's really only 10 independent compactified spatial dimensions. So that's the geometry of our universe. Now, what this suggests for space travel is the following. Our universe is one of many universes in the metaverse. There's many, many universes out there. And so if we're able to step outside our 26 real dimensional space, step outside of it into the metaverse, and then step back into it, we'd effectively touch two different points together, which in the world of algebraic geometry is called torsion. We torque or crinkle these dimensions that touch together. So we instantaneously travel between any 2 points is one way to view how you achieve faster than light travel. The temporal dimensions give us the possibility of time travel. Here we have the possibility to step outside. We have many timelines here, and we can step back in to some other timeline. So, for example, what has been observed is that a number of people have gone through hypnotic regression into past lives. And there's been a number of people that came across their memories of them living through the South, winning the Civil War. But the timeline that we're in, the North won the Civil War. So there's an alternate timeline there where the South won the Civil War, and so it goes. That's one way to step outside of time. The other way is to deal with the Akashic thread and step off the thread into some either past life or future life. And in doing so, this is what we do in hypnotic regression. We follow this Akashic thread back and forth in time. And so this is how time travel or faster than light space travel occurs. This is a picture here showing what we were just talking about with the 10 dimensions for matter here, the 10 dark matter dimensions here, and the 6 synchronizing dimensions here. You could say this is upside down, that actually this is the higher entity here, but this is the way we drew it. And then we have this other issue of we have information everywhere throughout the universe that controls everything, controls all the forces through algorithms and senses what's going on. And undoubtedly, this information is able to step outside our universe and be able to connect everything together, to be able to handle what we call physics that then leads to chemistry, that then leads to biology for matter and for dark matter. And so it goes. So let's go into a real concrete example. The Philadelphia experiment, which took place in, some say August 1943, others say October 1943. So what was the issue here? At the start of the Second World War, Nazi submarines were sinking millions of tons of shipping. In 1942, over 1,000 ships were sunk by Nazi submarines crossing the Atlantic Ocean. The U.S. Navy put together convoys, for example, with destroyers, but the destroyers had relatively large turning radiuses compared to when the submarines are very small compared to them. And so the end result was submarines could run circles around the destroyers. So the Navy developed something called an destroyer escort, something much smaller, but really designed to kill subs. This is a picture of one here. The one we're going to be dealing with, the destroyer escort, was called the USS Eldridge. So the U.S. Navy was looking at every possible technique to save the shipping and to take care of the Nazi submarines. And it turns out in the early 1930s, Nikola Tesla had come across some ideas to reduce the electromagnetic signature of a ship so that the torpedoes couldn't track the ship. In fact, the Nazi submarine torpedoes had a funny little quirk to them, which is if they went by and missed the ship, then the torpedoes went back to where they came from. And there are a number of examples of Nazi submarines that were sunk by their own torpedoes when the torpedoes missed. I have no idea why they wanted to do that. So in this experiment here that Tesla generated, the idea was to wrap some heavy copper cables around the circumference so they go bow to stern, bow to stern, bow to stern. Really, and the cables had twist to them, a certain amount of twist for every meter, and so forth. And then they were hooked up to the generators that actually drove the ship. And the generators are able to generate 5 megawatts of power, which is significant. And so Tesla developed a special controller that modified the electromagnetic field here that powered the cables. And that was the secret sauce that they hoped would lead to the ship being invisible. So what in the world happened? But here's an overview of this USS Eldridge. It's 300 feet long, 36 feet across, can do 21 knots, and has a crew of roughly over 200 on it. Okay. So let's take a look at what Tesla had to say in 1917. After he received the Edison Medal, which is a very prestigious award, he gave an interview to the Electric Experimenter magazine. And the topic of the discussion turned to the detection of German U-boats or Unterseeboot, or submarines. This is during the First World War. The United States had entered the war in April of 1917, and Tesla's concerns centered around the detection of the submarines and the possibility of some sort of non-ferrous, non-iron-based hull detection. So Tesla says the following: suppose we erect on the vessel a large rectangular helix or an inductance coil of insulated wire. Actual experiments in my laboratory in New York City have proven that the presence of a local iron mass, such as the ship's hull, would not interfere with the actions of this device. To this coil of wire measuring maybe 400 feet in length by 70 feet in width, which is pretty much the dimensions of the Eldridge in 1943, we connect a source of extremely high frequency and a very powerful oscillating current. So, for example, if you went to a high frequency, say 1 million hertz, and a very high power oscillating current, the currents levels we're talking about here can generate again 5 megawatts, which is significant. If we had a million volts, then we'd have 5 amps. If we had 5,000 volts, we'd have 1,000 amps. So it can be significant when especially when it's oscillating at these frequencies. So Tesla was already onto something here. A key individual was Vannevar Bush, who was Franklin Roosevelt's science advisor. He was aware of Tesla's suggestion. And the article in this 1917 magazine describes a technique which subsequently became quite popular for metal detectors and for tuning the reactance of RF coils in transmitters and receivers. And upon further prodding, Tesla discussed a high peak power microwave radar for operating at wavelengths about a few millimeters. This would be at 10 gigahertz. Which is what today is, maybe a factor of 4 above what cellular telephony operates at, and has a wavelength of 30 millimeters. So Tesla was already onto radar here. Tesla probably was onto radar in the year 1900. He desired that the ship be able to provide sufficient electric power. And in World War II, this was possible. The average ship here in World War I had to generate 10 to 15,000 horsepower. And so a fraction of this could be taken away to do something. But you know, the problem that Tesla faced was that people just didn't know what in the world he was talking about, because he was doing experiments that other people hadn't done. And he was also a far better theoretician and analyst than any of them. So Tesla recognized that he could characterize different spinning eggs. He took a spinning egg with a certain gyromagnetic resonant frequency. This is in 1887. This is like unbelievable. He's so far ahead of everybody. And in pulsing these currents through this egg, for example, the egg would spin. The vessels that are wrapped in coils, this was widely used for minesweeping and also for what became called degaussing studies, things where the magnetic field of the ship could be significantly reduced, meaning the torpedo might miss it. Hertz had observed standing waves from metallic reflections, but Tesla was the first to propose the concept of radar, and he suggested using electromagnetic waves to determine the relative position, speed, and course of a moving object, which today we take for granted, but this is how far ahead of us he was. The earliest patent apparently went to some Brit, but by the way, the term radar uh, is the word that was used for the MIT radiation laboratory, where it was not dealing with atomic radiation, it was dealing with microwave radiation and dealing with radar. Developed radar, sonar, and LORAN, which was a radio system for position location. So this is all due to Tesla. So the phrase came about called degaussing a ship to prevent mine detection. Now, the Nazis had mines that detected the increase in the magnetic field when the steel in a ship concentrated the Earth's magnetic field over it. That's what steel does. So the Brits developed a number of systems to induce a small North Pole upfield into the ship to offset this effect, meaning the net field was the same as the background. So since the Germans used Gauss as the unit of strength of the magnetic field in their mine triggers, this technique that the Brits developed was called degaussing. It got rid of the magnetic field there. And this became widely used. And what happened to degauss a ship, you installed magnetic coils into the ships. They were just simply known as coilings. And to be able to bias the ship continually, coiling allowed the bias field to be reversed in the southern hemisphere, where the mines were set to detect the South Pole down fields. That's because you're in the southern hemisphere. So this was all done sometime around 1943 for all British ships. That is, they were all degaussed, and the German mines that used this magnetic phenomenon to detect the ships were useless. So that takes us up to this Philadelphia experiment. Here we come to October 26, 1943. The USS Eldridge was moored in the U.S. Navy Philadelphia shipyard. They had the heavy cables around the ship. The power generators are there, generating 5 megawatts of power. And there was this controller that Tesla had developed. And they hooked it up. And when it started up, the ship disappeared for roughly 2 hours and then reappeared. Now, what happened was that actually when they started it up, 20 minutes before they started it up, the ship disappeared in Philadelphia and appeared in Norfolk, Virginia, in the U.S. Navy shipyard there. But this was 20 minutes before they actually started this. So here we have an evidence of time travel of a ship. And it, after a few minutes of being in Norfolk, Virginia, it disappeared. And apparently the Germans were carrying out similar experiments in the Kiel shipyards in northern Germany, 1943, and they encountered similar sort of phenomenon, which led them to abandon it, just like the U.S. Navy, as we'll see, abandoned this. So the experimental ship mysteriously disappeared from its Philadelphia dock, showed up only minutes earlier in Norfolk, and then vanished again, and then reappeared in Philadelphia. But suddenly there was a deep fog that flashed off that led to, what in the world was I doing in Norfolk? The person writing this recognized this as Norfolk because I'd been there to the ship's other dock there. And then just as suddenly the green fog returned, and he's back in the Philadelphia Navy Yard. So looking at the harbor from the dock, there were 5 British seamen in Norfolk who were amazed to see all of a sudden a cloud suddenly form in the harbor and then almost immediately dissipate, leaving a destroyer escort in full view. It stayed a few moments, and then it was covered up by a cloud and vanished again. So there's a green fog and mist, and after a time, the central ship, a destroyer, disappeared slowly into the transparent fog until all that could be seen was an imprint of the ship in the water. So that you can see an imprint of the ship in the water, you can't see the ship, the metallic ship. When the field or whatever it was turned off, the ship reappeared slowly out of thin air, out of the fog that was there. Then the green fog returned. The men on the ship were apparently able to see one another, but all that could be seen by anyone outside of the field was the clearly defined shape of the ship's hull in the water. The ship became invisible to human eyes, and yet you could see impressed in the ocean water the shape of the keel and the underhull of the ship. And the field was effectively an oblate spheroidal shape, extending probably 100 yards out from each beam of the ship. So anyone outside that could see nothing except the clearly defined shape of the ship's hull in the water. There were a whole number of people involved in this. Tesla was the one who probably started it all, but Albert Einstein was a consultant involved, and many other people here, as you can see in this list, were all involved in doing this, many of whom had very, very distinguished careers. I touched briefly on this egg of Columbus that Tesla had developed. So let's just go back and look at this, see what he did. There's a time varying magnetic field, so it's oscillating, and it generates, therefore, eddy currents in salt water, which in turn react back on the magnetic source, opposing changes in the source field. So Richard Feynman says the following: suppose we have a sheet of a perfect conductor and put an electromagnet next to it. When we turn on the current in the magnet, currents called eddy currents appear in the sheet. There weren't any currents until we turned this thing on. So there's no magnetic flux that can enter the sheet because of these eddy currents. They shield it. If we take a bar magnet near a perfect conductor, we see the same thing. So this makes it possible to suspend a bar magnet in air above a sheet of a perfect conductor. If the conductor is not quite perfect, there'll be some resistance to flow of the eddy currents, and the currents will tend to die out. The magnet will slowly settle down. So the eddy currents in an imperfect conductor need an electromagnetic force, or an EMF, keep them going. And to have an EMF, the flux must keep changing, and that's why there's an alternating time varying field here. So the flux of the electromagnetic magnetic field gradually penetrates the conductor And in a normal conductor, there are only repulsive forces from the eddy currents, but there can be sideways drag forces which prevent lateral motion. So here we see this egg sitting here, and it's actually suspended, floating over this oscillating this sheet of metal that has a magnetic field varying all around it. So this is from Tesla, Tesla's lab in New York City. So the circulating AC eddy currents would agitate the seawater at acoustical frequencies. You could hear this. So this would make steam, mist, and fog. And in all probability, hollow out a cavity underneath the magnet. So consider what happens when you have a high current AC electromagnet in a plastic tub of salt water. So if instead of dragging a conductor past a magnet, we try to rotate it in a magnetic field, there'll be a resistive torque which will fight this. And if we rotate the magnet near a conducting plate or ring or a conducting egg, the ring or egg will be dragged around and follow this. The currents in the egg will create a torque, tends to rotate it around or spin it, and so it goes. So we have a rotating magnetic field, and the rotary drag torque produced on the conductor by such a rotating field is shown by standing on a metal ring on an insulating table just above this torus, and so it goes. So what happened here in the Philadelphia experiment apparently is there's a boiling of water or ionization of the surrounding air, and the atoms, in fact, gave up some electrons. There were some energy transitions here called Zeeman transitions. And this ionization created by the field tended to cause an uneven refraction of the light. The result would not be a steady mirage effect, but rather moving back and forth displacement caused by certain inherent tendencies of the AC field. So with proper effort, some of these problems could be overcome. There could be a resonant frequency sound that would possibly control the visual apparent internal oscillation, so the shimmering would be much slower rate. And you could expect that the power dissipation on the water doing to the eddy currents to heat up the water, perhaps generating steam, and the sea would be a heat sink for any of this heating. There'd be a good deal of turbulence near the ship, and ionization in the air could result, all of which was apparently observed. So observers said, I felt the push of that force field against the solidness of my arm and had outstretched into its humming, pushing, propelling flow. And so in trying to describe the sounds the force field made as it circled around, it began as a humming, whispering sound and then increased to a strongly sizzling buzz like a rushing torrent. And there's a series of electric power cables that had been laid down from a nearby powerhouse to the ship. Switches were thrown, and so this led to a whine that was almost unbearable. It seemed reasonable to assume that the media immersed in the bias coils low frequency magnetic fields, meaning the ship and the seawater, would respond to mechanical vibrations, much like the acoustic hum of conventional power transformers. We've all heard power transformers humming. The sea and the seawater have become the output of an acoustic transducer driven by these coils, and more than likely the power content would be substantial well into the ultrasonic region and lead to an unbearable whine. We couldn't stand the effects of the energy field they were using. It affected us in different ways. Some only saw double. Others began to laugh and stagger like they were drunk. A few passed out. Some claimed they passed in another world and they had seen and talked to alien beings. Any person within that sphere became vague in form, but he observed those persons aboard the ship as though they were of the same state, yet were walking upon nothing. So as you stood there trying to comprehend what happened, you saw indistinct figures in motion, could not identify as sailors, and some other shapes that did not seem to be long on the dock, if in fact that's where you were. Besides this flicker, there was a whole spectrum of subjective abstract light patterns excited in the brain. And the shapeless figure covered a large frequency range, but could excite things between 5 and 35 pulses per second, which is where a lot of the wave forms in the brain take place. So this had significant impact on driving people crazy. And so it goes. So there were many light patterns observed, such as stars, wheels, asterisks, bright dot patterns, moons, smiley faces, and other geometrical shapes, and reports of magnetically stimulated phosphenes, so forth. The intensity is greatest between 20 and 30 hertz, and above 90 hertz, the phenomenon becomes less evident. The luminosity appears to involve more and more of the visual field, and so forth. So these, there were magnetos sphenes and Purkinje figures, which you can look up. They're Johannes Purkinje was a Czech physiologist in the 19th century who said deceptions of the senses are the truths of perception, meaning that illusions call our attentions to the workings of the visual system, whereas normal perception fails to do so. So he studied a number of variously shaped subjective optical patterns that could be excited by electrical stimulation, and the end result was he ended up with a whole series of patterns uh, that actually go back to work from Benjamin Franklin and Volta. Uh, just so following on the clue that a low frequency electromagnetic pulse spectrum was involved, these patterns observed and so forth by the people on the ship. So could it be possible that as a result of magnetically biasing the ship to be stealthy toward radar, that there were torsion deformations that were excited in the fabric of space-time itself? So in fact, all of a sudden we step out of space, we're in Philadelphia, and we touch space again in Norfolk, Virginia, but we happen to do it 20 minutes in the past. That is, when we start up in Philadelphia, it's already 20 minutes earlier that we've appeared in Norfolk, Virginia. So this is why I said it's important to think of this as a geometric effect or a torsion, where you step out of space and time and step back in again. And the end result of this is that all of this is quite plausible, and so it goes. So, is it possible that you could actually do this? Yes. The question is, what was the controller? What in the world was going on here? That the controller was originally put together by Tesla, and what in the world was he thinking of that would allow you to do this? But that's a story for another day. There's a lot of literature on quantum mechanical spin and torsion for space-time. Einstein had a big push in 1929 for unified field theory. He worked with the French mathematician Elie Cartan, and they had their own unified field theory, and so forth. But the main thing was there were temporal jumps due to what is called anholonomity, and there were also jumps due to torsion or skipping around. So we're just going to do a brief digression here. It turns out that the thing to keep in mind is there are two different phenomena, but the net effect is that the stepping out of the space that you're in and stepping back in elsewhere is the same effect for them, and so it goes. There were a number of physicists that identified with this. This doesn't have anything to do with the curvature of space-time, because you're actually crinkling space-time to touch, go from one point to another. If you take a towel and you touch two different points, you would end up moving from one place to another, which could be a point in space, it could be a point in time. The end result is that this appears to be what happened in this Philadelphia experiment, except that no one knew what was going on. Here, I'm just talking about the theory that Elie Cartan came up with in 1922, and he worked with Einstein on this to link things up, but weren't able to. But many mathematicians looked at this and they say there's probably something here. They just don't know what to do with it. But the main concept here is folding of space and time. Probably is what happened in this Philadelphia experiment, except that no one knew what they were doing when they did it. And that's it for today. Have a good, all the best.